Okay, we're going to talk about writing systems of equations. So remember, if you have the opportunity to make a table of values, then you can use your calculator. So that's what you would use for a table or a graph. So I'm going to clear my calculator. And for systems, this is when you're going to have two or more equations. So we're going to have to do this twice, one for one table and one for the other. So I'm going to go 0, 1, 2, 3, 4, 7, 6, 5, 4, 3, stat over 4, and A is equal to -1, B is equal to 7. So my first equation is going to be y equals negative x plus 7. Notice I didn't write my 1, I just wrote the negative to show that it was a -1. And so now I'm going to clear my calculator, and I'm going to stat enter, and I'm going to type in my second table. 2, 3, 4, 5, 6. 3, 4, 5, 6, 7. Stat over 4, enter. And A is equal to 1, B is equal to 1. So it's going to be y equals x plus 1. Those are my two systems of equations. All right, so now onto the graph. I'm going to clear my calculator first. Okay, so the same thing for the graph. So I'm going to make a table of values for 1. Okay, so I'm going to call this number 1. All right, so I've got -2, 0, and 0, 1. Now remember, I could pull off, there's also a good point here, and a good point here, and a good point here, but I only need 2. So I just picked 2 random ones. Any of those 2 would work. So I'm going to stat enter, and -2, 0, 0, 1, stat over option 4 for a line, and my equation, my A is equal to 1/2, and my B is equal to 1, so y equals 1/2 x plus 1. And now I'm going to clear my memory, and I'm going to do the exact same thing for my next line. So I've got to pick off 2 good points. So here we go, -4, -1. And then I've got 0, -3. Again, there are more options I have for good points. Those are just the 2 that I chose. So stat enter, -4, -1, 0, -3, stat over option 4. And A is equal to a -1/2, which matches because it's slanting down. And B is equal to -3. So my equation is y equals -1/2 x minus 3. And now we're going to look at word problems. So when you're matching up word problems, take it sentence by sentence. Okay, so the perimeter of a rectangle is 72 inches. Okay, so I know I've got a rectangle. And I know that the perimeter is 72 inches. And that's after I add up all the sides. So I'm going to have 2 lengths and 2 widths to add up. Let's see if I've got some more. The length is 6 inches greater than twice the width. So I have to take twice the width and add 6 to it to get the length. Okay, so here's what we're going to do. So the perimeter, I know I have to add 2 lengths and 2 widths to get my perimeter. But the second sentence says the length is, remember, is means equals 6 inches greater than. Greater than means I'm adding 6. Twice the width. So twice means 2 times. What are we multiplying by? 2w. 2w. And those are my 2 equations. Now I would have to decide, is length going to be x and width going to be y, or do I need to change it up because when I go to my calculator, the L's and W's have to become x's or y's. So you just have to make the choice and decide on your paper which one do you want to specify as x or y. It doesn't matter. All right, solving systems. So remember, types of solutions. If you have one solution, you're going to see an intersection point. Okay? If they're parallel lines, no solutions. If you have infinite many solutions, that means that when you graph both lines in your calculator, you're only going to see one single line because they overlap. Okay? You can solve by graphing, substitution, or elimination. I prefer graphing if you can, because you have two equations and you can graph them in your calculator and you can go second trace 5 to find the intersection point. So that's exactly what I'm going to do here for example 1. I'm going to graph, so I'm going to pick off 2 points. I've got 0, 1, and I've got 4, 3. So I'm going to clear my calculator, and I'm going to go straight to stat enter, and I'm going to type in 0, 1, 4, 3, stat over 4, and I've got y equals 1/2 x plus 1. Okay, since this is a system, I need 2 lines. So I've got to get my other points. So stat enter, and I'm just going to type over the 2 points since I'm not using anymore. So I've got -3, 0, and then I've got 2, -1. So I typed over my 2 points. So I'm going to write those down. -3, 0, and 2, -1. All right, so stat over 4. And my second equation is going to be y equals, that would be 2/10, so -2/10 minus 6/10. Now, I could simplify this to 1/5 and to 3/5, but since I'm just going to type these in my calculator so I can graph them, I'm going to let my calculator worry about that. Remember, I'm trying to do some things that save time. So I'm going to type in 1/2 x plus 1. And -2/10 x minus 6/10. And then I'm going to hit graph. And they should cross. Okay. Now if I look at my picture, something's wrong. Oh, because this point is not 0, -3. It's 0. Okay, so I need to go change something. So I need to change that to 0, -3. So if you graph it and it doesn't look right, then you need to go check your work. Okay, so this is going to be 1, 3. Okay, totally new equation. Y equals 1x minus 3. And now I'm going to go back in and change my equation. X minus 3. And so now I'm going to graph. There's y1. There's y2. That looks better. And I see an intersection point in my viewing window, so I don't need to adjust my screen. So second trace, option 5 for intersection point. And you're going to hit enter 3 times until you see the word. The word intersection tells you have your answer, and my solution is the point 8, 5. They cross and meet each other when x is 8 and y is 5. Okay, example 2. They've already given you the equations. So this is ready to go in the calculator because I see y equals. This one is not, so I've got to rearrange it. So I need to move that 4x over, and it becomes a -4x. So now I have 1 y equals. So I've got y equals 5x plus 1, and y equals 10 minus 4x. So you might have to do some rearranging. So I'm going to clear my calculator. I'm going to go to y equals, and I'm going to type in 5x plus 1. 10 minus 4x, and I'm going to hit graph because I need to see the intersection in my viewing window. I don't have to zoom out, so I'm going to hit second trace 5, enter, enter, enter. I see the word intersection, so I know I have my solution, and my point is at 1, 6. So on a graph, if I were to graph these by hand, they would meet each other at the point x is 1, y is 6. Okay, for a table of values, what you want to do is you want to be able to, they have to have the same x and the same y value. So I'm looking for when x's are the same. 0 and 2 are not the same. 1, 2. Okay, here's the same x, but now I'm looking at their y value, and their y value is not the same. So I'm going to mark them out. Okay, again, x is 3. Okay, there's a 3 and a 4. So they have the same x and the same y. I'm going to look and see if they have any other points that are the same. Okay, there's the same x, but notice their y's are different. One is a 3, one is a 5, so those don't match. So their solution point is when they have the same x value and the same y value, and that is when x is 3 and the y value is 4. That is their solution. So if we were to graph this, we would see them cross or meet when x is 3 and y is 4. That is the point they would cross or intersect at. All right, so for these, we have two equations and I have to rearrange. So I'm moving my x over. So I have a negative 1y. So I need to divide everything by a negative 1. So I get y equals negative 1 plus 1x, which is just x. And then same thing, I've got 3x minus 3y equals 3. I want to rearrange, so I'm going to move my 3x over and divide by negative 3. Y equals negative 1 plus 1x. And now I'm going to graph these, so I'm going to clear my calculator. So I'm going to go to y equals, I've got negative 1 plus x, negative 1 plus x. And since I'm graphing both of them, I'm going to go ahead and change it to a thicker line. So there's one. And if you notice, y2 graphed right over it. So they are overlapping lines. And if you remember, if they are the same line, that is going to mean infinite solutions, because they share every point in the line. Infinite solutions. And I'm also going to show you what that looks like in the table. So remember I said in the table they have to have the same x and same y values? Well, if you look, the y values match every single time, up and down the table. And if I go to the negative x values, you're going to see the same thing. Same, same, same. So they share every y and x value, so that's why it's infinite solutions. Okay, so here I'm going to make this y equals, so I'm going to move this 1 over, so it's going to be y equals x plus 1. And I just need to move the x over here, so that's going to make that y equals negative 1 plus x. And we're going to graph this. I'm just going to go to my y equals, and I'm going to clear it out. And I'm going to type in x plus 1, negative 1 plus x, and I'm going to change this just so I can differentiate the two, so I can see the difference. Okay, there's y1, x plus 1. There's y2, negative 1 plus x. And what kind of lines do you see? Those are parallel lines. And parallel lines will never intersect, which means they will never share an x and a y value. So this is no solution. And I can also verify that in my table. For every x, their y values will never match. So now I'm going to go into some of the positive sides. They're never going to match. This x keeps going up, this x keeps going up. They're never going to meet. So that's how you know that they are no solutions. All right, now you're going to look at direct variation and some more equations of lines to finish out category 3.